We are talking about raster analysis, and in part 1 of the tutorial you calculated the slope cost for a given new development. In this tutorial you will use the drainage data to find the cost because of the flood zones. To find out the distances from a given line or polygon, there's a function in the spatial analyst tools. It's called distance group, and inside distance there is Euclidean distance. If you double click Euclidean distance, you can find the buffers as a raster image around a given map. So in this case we will use drainage map, and we are trying to find the drainage buffers around it, so let's call it drain dist. And there is no need to provide any maximum distance, but there is need to provide the cell size. Now in our case we are using 10. The DEM data is available as 10 meter by 10 meter, so you will use 10 meter as the cell size and click OK. If you see, this has created buffers around the drainage map. Of course you can see that the buffers are not covering the whole area of interest, and some of the parcels are outside. So I will teach you a new method that you have not covered so far in dealing with such a problem. So go ahead and start the Euclidean distance tool again, but this time select the drainage map as before, and let's call this drainage dist 2. And set up the cell size to be 10 as you did before. But there's a button called environments, and click this. You can use this button to change a lot of things about this map that is to be output. The one we will be using is called processing extent. So we will tell it that use the extent of the DEM data when it is making the output. That way it will create the output for the whole area. And let's click OK, and you have already given the name. Click OK. You will see that in this case it has created a proximity or Euclidean distance map for the whole image corresponding to the extent of the DEM. Again, if you click identify and select any button, any pixel, make sure that you have the drainage distance 2 selected. You will see that it has a value which is its distance from the drainage the drainage channel, and it increases as you move away from the drainage channel. We're going to use this information to find out the cost. In order to do that, we will use a tool called Reclassify. You can look for it, Reclassify, and it's the spatial analyst tool, Reclassify. And in this one you can select the drainage map, and you will see that it has all the different ranges. What we need to do is the table that you have been given in your exercise Word file, that's the table we would like to use. So we will click Reclassify, and we will create 6 classes which are given in your table in your exercise, and create manual breaks. And this is we have 0 to 100 meters, then 100 to 200 meters, 200 to 300 meters, 3 to 400, and then 500, and then greater than 500. So we will use that, and notice it is going to use these as the old classes. And now in the new values we will associate what the price of development for these ranges is. So if you look at your table, for the 0 to 100 meters distance, the cost is $250 per square foot. Again, this is the cost per square meter. This is the cost per square meter, but for the whole cell, which is 10 by 10, it will be $2,500 250 times 100, which will be 25,000. So in a similar manner, for 100 to 200, it will be 200 or times 100 or 20,000, so on and so forth. So we will fill up the remaining values in a similar manner: 10,000 and 5,000 and 0. For anything greater than 500 meter and beyond, there is no additional cost because of the flood zone. Now also provide an output here, and let's call it cost because of flood, so call it flood cost, and click OK. The output of this process will look like these buffers around the drainage, and if you click identify and click in these points and make sure that you have selected the flood cost, you will see that these are actually values of the cost. So 25,000 in the flood zone, which is the closest to the drainage channel. The next is 20,000, 15,000, 10,000, 5,000, and once you go beyond 500 meters, there is no development cost for flood zone. So as you can see, this is how we have created the flood cost. Now the next step is pretty straightforward. You need to calculate the total cost, and that you can do using Raster calculator. And let's calculate it as total cost. So remember, in your exercise, you're given that the baseline cost is 20 per square meter. So for a cell, it will be 20 times 10 times 10, which would be $2,000, plus whatever is the cost because of the slope, plus whatever is the cost because of the flood cost. And let's call it total cost and click OK. This will produce a map which gives you the cost of development of different cells. If you click identify and find out what the values of different cells are in terms of their total cost, you can see that the high elevation areas that are close to flood zones have the highest, are the most expensive to develop, whereas areas in the plains and farther away from the drainage channels are cheaper to develop. So this gives you a map of cost for each cell, but that still does not gives me the value how much will it cost to develop this whole parcel. To do that, you will use a tool called Zonal statistics. So just type Zonal in your search and look for Zonal statistics as a table, and in this you can provide the zones, which in our case are the parcels. So each parcel is a zone, and I would like to calculate the value total cost, the sum of all the values within a zone. So this process will calculate the total of all the cells that fall in a given parcel, and then you have a given output, so call it parcel development cost. It will output as a table, and click OK. You will see that a parcel development cost map has been created. If you open it, you will see that for each parcel number there's a sum or dollar value of the development cost. You can join this table to your parcel map by using the join technique that you have learned before, and make sure you join it with parcel tag, and this will join it. Click OK. Once you have joined the attribute table for the parcel map to the table, you can go into properties and adjust the symbology based upon the one that is given in your exercise. So anything less than 20k is green, between 20 and 40k is blue, so on and so forth. And if you click OK, you will see that all the parcels are now color coded based upon how much will it cost to develop them. This concludes our tutorial on raster analysis.